Okay, hopefully we are ready to go. So the topic here is the present value of an annuity and amortization. Amortization refers to a mortgage, which is a loan that you pay. It's basically an annuity in reverse. It's a loan that's based on an annuity. Whereas an annuity is something you pay into and get money at the end. A mortgage, whether it be a car, a house, or just a personal loan, is something where you get the money out on the front end, and then at the end you get to keep the property that you borrowed it for. So the first thing we're going to talk about is the present value of an ordinary annuity, which the formula looks like this, but as we've done through the whole thing, it's not something we're going to do with a formula. You don't need to use the formulas. We're going to use it with the TVM solver. So here's our first example. We have two people, Carol and Tim, that are graduates of BIT, and they both agree to contribute to an endowment fund for their school. And Tim says he's going to give $500 at the end of every year for 9 years. Carol doesn't want to do that. Carol wants to give a lump sum today that will be worth the same thing as what his will be when the time, when the maturity of his investment comes around. So the question we have is, what lump sum can she give that will equal the present value of his annual gifts if the endowment earns 7.5% compounded annually? So what we've got here is we've got a series of payments, which is $500. And those $500 are going to be at the end of each year. So that tells us that this is going to be a regular, ordinary annuity for 9 years, compounded annually, so there'll be 9 compoundings, and the interest rate is 7.5%. So what we'll do is we'll take our TVM solver, make sure that's where everybody can see it well, and at the TVM solver, we know that N is the number of years times the number of times per year it's compounded. So that's going to be 9 times 1, 9 years times once a year. The interest rate is 7.5%. The present value is what we want to know, so we're going to leave that as 0. The payments are a cash outflow, and that's $500. The future value is not what we're interested in. We really could care less about what the future value is going to be. We're not interested in that. So we're just going to enter a 0 for that. Compoundings per year is 1. And since it's an ordinary annuity, then the payments are made at the end. So we go back up and solve for the present value. So the present value, or the amount of money that it's worth today, is $3,189. And 44 cents. So that tells you that Carol will need to deposit of that same amount, $3,189.44, now at 7.5% compounded annually, for 9 years to match Tim's gift. Now, if you're curious as to how much Tim's gift is and does hers actually equal out, what we'll do is we'll go down here, take out her payments because she's only going to deposit a lump sum, calculate her future value. So her future value is $6,114.92. Assuming that she has the same interest rate and compounding periods. Whereas Tim's gift, without worrying about his present value, should give us the same amount. And it does. So the only difference between the two gifts is he's contributing his $500 a month for 9 years, or $500 a year for 9 years.
But that's $4,500. So
yeah.
That's what doesn't make sense. I mean, how is it equal if she's doing $3,189 and he's paying $4,500?
Well, because she's only wanting to match his future value, so she's actually getting off cheaper than his.
Yeah.
A lot cheaper. Because he's not paying it all up front. She's turning loose of it all up front. So remember, his payments are going to garner interest through the years. Her lump sum gets a lot more interest at the beginning and then continues to gain interest.
Yeah, it's almost like he's charging himself interest.
Yeah, it's almost like he's charging himself interest.
Yeah, that's what didn't make sense to me. I'm like, how could that possibly be?
Yeah, his payments total more than her one single payment does.
Out of pocket money.
Right. So she's smarter than him.
Exactly. She said it a little bit.
She's smarter than he is. But then again, maybe he doesn't have $6,000 to start with. So, you know, that could be a consideration. So now for our second example, we've got a car. We want to make car payments. A car costs $19,000. You're going to pay $2,000 down, which is normal, around 20% down, or around 10% down. The balance will be paid off in 36 equal monthly payments with interest of 6% per year on the unpaid balance. Find the amount of each payment. Okay, if you're going to borrow the car, this is the actual cost of the car today. But that's not the present value. Because you're actually only going to borrow $17,000. So there's your present value for your loan. See if I can't move that so we can make that actually a little bit bigger. There we go. Now they're going to make 36 monthly payments. And the interest rate is 6% per year. But if they're making monthly payments and the interest is being charged on the unpaid balance at the end of each month, that means that the compounding periods and the payment periods are both going to be 12. So what this tells you is that her loan is going to be paid off, or his loan, in 3 years. So this 36 monthly payments is 3 years times 12 payments a year. So that means the value of N is going to be 36. Now, we're not interested in the future value of that loan. Well, we probably would be if it was us. What we actually want to know is how much is each payment going to be. So that's what we're going to solve for. So there's going to be a number, the number of payments is 36, which is going to be 12 times each year, 12 compoundings per year. We're not interested in the future value. The present value is the $17,000, which is the amount we actually borrowed to buy the car. And we want to know what the payments are, so we're going to set that to 0. And you're going to make your payments at the end of each month after you've actually borrowed the money. Yes, and we have to change the interest rate to 6%. So we need to make a note of that. Now, the present value of the car, in this case, is money that they paid to us, we're having to pay it back, okay? So they paid us for the car, at the end, we're paying them back the money. That future value is going to be negative. So that means our payments actually are going to come back as being positive. So we're going to do alpha solve. I'm sorry, our payments come back as being negative because payments are being paid out for the amount of the loan in this case. But the future value of that loan is you paid the bank back a total of this much money and you get to keep the car. So the payment amount are $517.17 for 36 months. Now, if you pay that $517.17 for 36 months, you have paid $18,618.12 for the car. That's the future value of the loan. That's the total amount that you paid back. So if we were to go in here to the solver, and treated this like it was a mortgage rather than a loan, and get the future value, you see that the future value is not the total of the payments and the interest. The future value doesn't consider the $2,000, although that would be a tempting thing to consider, given that it's about $2,000 more. But what makes it different is the fact that the total or the future value of just those payments took into account no present value. Okay, so it's like you're actually paying interest as you go along.
You just paid almost $23,000.
Yeah. Because the only time that this would actually be true would be when it's actually simple interest and the same amount was going to the principal and the interest every month. So this is how you do both of those problems on the TVM solver. And now we'll talk about a mortgage. And this is about the point, I've had students in the past that always like to do everything with the formula. Let me do the formula. I don't like using that calculator. I want to do the formula and do all the arithmetic. And I tell them, okay, fine, but when it comes in here and you don't put all your parentheses in right, remember the problem we had last week where we were trying to build that table and being very careful about parentheses? This formula gets ugly trying to put in parentheses because you've got so many of them. But a loan is amortized if both the principal and the interest are paid by a sequence of equal periodic payments. That loan of $17,000 at 6% compounded monthly could be amortized by paying $517.17 a month for 36 months. That's why it refers to being amortized, even though you think mortgage, usually think of a house. But any kind of a loan is actually a mortgage of sorts. So if you turn it into that situation, we can talk about home mortgages. So here's one problem about a home mortgage. The Perez family wants to buy a house, or they buy a house, for $275,000. That's the actual asking price. But they make a down payment of $55,000. They take out a 30-year mortgage for the $220,000, which is your $275,000 minus your $55,000, and the annual interest rate is 6%. But they're going to make monthly payments, remember. That's 12 payments a year. So find out the monthly payment needed to amortize this loan. So we go to the TVM solver, and the number of payments for a 30-year mortgage, 12 months out of the year, is 360. So they're going to make 360 payments with their annual interest rate of 6%. What they initially borrow is the $22,000. I'm sorry, $220,000. Got to add enough zeros. And what we would like to know is, what are their payments? And we're not interested in their future value. We're interested in the payments. So we're going to solve for the payment. Oh. And their house payments are $1,319.01. So there's their monthly payment. Now the question is going to be, when this loan is amortized over 30 years, how much interest in the long run are they going to pay for this? And that one shouldn't be too hard to figure out, because they're gonna make 360 payments times that amount for each payment. Now that's the total amount they're gonna pay for their house. $474,000, $474,843.60. That's how much they're actually gonna pay for the house. Give up. But that doesn't take into account the fact that they borrowed $22,000. $220,000. So they paid $254,843.60 in interest. They paid more in interest than they paid for the house. And that's common. Now this is a fixed rate mortgage. That's one thing that you need to take into account. We don't always have fixed rate mortgages anymore. We have some that are still sliding mortgages. That's where they'll either for a period of a year or 2 years or 3 years, you have this interest rate, and then they tie your interest rate to the prime lending rate. And it'll be like the prime plus 2 or 3 percentage points. So that they'll check the prime periodically during the life of your loan and adjust your actual interest rate up and down during the life of your loan. Which means that the calculations will change and your payments will change. I can tell you from my own perspective, my initial house payment when I moved into my house was $780 some a month. At the end of the first year, it was adjusted up to $876 a month. Then it was adjusted up to $902 a month for a year or two. And now they've adjusted it back down to $812 a month. So I never know from one year to the next what my house payment's gonna be. But I was glad to see it come back down to $812 a month. I wasn't complaining. So Part C says find the part of the first payment that's interest and the part that is applied to reducing the debt. This gets into the idea of making a mortgage table or an amortization table. So that's going to be the next thing we look at. So we've done Part 1 and Part 2, or Part A and Part B. Now we're going to do Part C. Part C is a little bit tedious to do by hand, even with a calculator. So before I get into it, let me explain what an amortization schedule looks like. They're making 360 payments to amortize a $220,000 loan. The loan balance after the first payment is reduced by only $219.01, which is a whole lot less than their loan payment. So even though the equal payments are made to amortize the loan balance doesn't decrease equally throughout the life of the loan. In the beginning, your every payment you make, most of it goes toward interest. And only a small amount of it goes toward the principal. Now, as you progress through the life of the loan, the amount of your payment that goes toward the principal increases because your balance shrinks and you have less interest to pay. So this is a very important fact if the loan's going to be paid off early. And to go back on this one for just a second, how do they know it was $219.01 out of the first payment? Their initial loan value was $220 or $220,000, and the interest on that one payment for 1 month remember it's simple interest for 1 month is 1/12 times the total interest rate, and that should be $220,000 times 0.6 over 12, 0.06 over 12. Help if I got my decimal in the right place. Is 0.005 per month. But that's on the whole balance because you haven't paid anything on it yet. Ah, that's 1,100. That's not right. What did I do wrong?
Yes, you take the 1319 and subtract the 1,100 from it, because 1319 is the payment.
Ah,
1319.01, and then subtract the 1,100.
that's right. Okay, so that's how much, that's the 1319 is your actual payment amount. Minus the amount of the interest, which was $1,100, means the amount that paid to the principal is $219 and a penny, which is not a lot. Now, what happens in the second month is you've actually reduced this amount by $219 and a penny. So let's talk about the second payment.
Sorry, I'm still confused on the first payment
Okay.
as to why this is happening. I'm just confused. I've never bought a house before, so I'm.
Well, it's better to learn here than it is after you bought your house.
Amen.
Okay. What happens is at the end of the first month, you haven't made any payments. This is how much money they loaned you. Okay? The loan is 6% compounded annually, but at this point, you've only paid interest for 1/12 of the year or 1 month. So 1/12 times that 6% is only a 0.5% interest. But that 0.5% times $220,000 is $1,100. So $1,100 of your payment went to interest. Okay? Yeah, ouch. That hurts. So even though you paid that much, this is how much your principal went down. Okay?
What is the principal?
The principal is the amount that you still owe. Okay? The amount you still owe on the loan is the principal.
Is that what you were paying on the house or something?
Uh-huh.
For forever.
Forever.
And
Yeah.
ever.
So at the point of the second payment, we go to the end of the next month. Think about it this way. We're going to go to the end of the next month. You're going to pay another $1,319 and a penny. But your principal has been reduced a little bit, a very little bit. okay? Your principal now is greatly reduced, $219,780.99. Okay? So here's your new loan balance. Now granted, that's less than the $220,000 from last month, but not a whole lot less, okay? And you are now going to have to pay interest on that amount for 1 month. So at this point, your amount of interest that you're going to pay is going to be $1,098.90. While you're still going to pay your $1,319.01. So that means the amount that's going to get paid to your principal is $220.11. So that's, what, about $8.90 difference? Not very much. Okay? And then you do that again. Every month you do the same thing. Payment number 3. Your new balance now is, let's see, $2197.80 and 99 cents, and we can subtract off $220.11. So now what you're going to pay interest on for this next month is $219,560.88. Which means your next interest amount is going to be $1,097.80. So when you make your next $1,319.01 payment, they're going to take $1,097.08 in interest. So you're going to get to pay $221.21 towards your principal, and you keep on doing that for 30 years. And very slowly, this amount gets smaller, and equally slowly, this amount gets bigger. So that's why it takes so long to pay off a mortgage, because the mortgage present value or principal is so much, and the payments you're making sound like a lot, but you're still paying interest on that huge principal, and it's coming out of every single one of your payments. Now the question comes up, is there a benefit to paying it off early? And the answer is yes. There's a great benefit. The earlier the better. So Cassie Morgan borrows $1,000 for 1 year at 12% interest compounded monthly. Her monthly payment is going to be $88.84, actually 85 cents. They've rounded it to 4 decimals, but I just went ahead and called it 85 cents. And after making 3 payments, she decides to pay off the remaining balance all at once. Now, if she took out a simple interest loan, she would gain nothing by doing this. Because all she'd be doing is paying the remainder of the sum of her payments for that loan, regardless of whether she paid them out each month or if she pays them all right now, it's the same amount of money. But because this is being compounded monthly, she gains an advantage if she pays it off early. So here's what's gonna happen. Make sure I've got the right notes, so if I mistype something, I don't mess everybody up. What we're going to do is we're going to do an amortization table, because that's where we're going to kind of need to be able to figure out her situation. Since it's going to be 1 year at 12% interest compounded monthly, those last three payments are $88.85 at 1% per interest period. That pen's had it. So what she's going to be doing is, we need to know the present value of those 9 payments of $885 and $88.85 each, and she's going to make those 9 payments. That's going to be her present value, because she's going to avoid having to actually pay that interest. So we'll go over here and do the annuity. And she's only going to make 9 payments. And her annual interest rate is 12%. And it's being compounded monthly, so we've got 12 and 12 for the P/Y and C/Y. Her payments would have been $88.85. And we need to know the present value of that. And somehow that was not what it was supposed to be. But, oh, I didn't change the payment amount. So the present value of those 9 payments is a whole big $761.09. So that would be her payoff amount after 3 months. And that's because most of her first 3 payments went to interest. They didn't go to reducing her principal. And the way that we're going to see that is we're going to look at the amortization schedule, and I'm not going to ask you to create one. Okay, I may ask you to explain one or to calculate little pieces of one, but once you see the pattern, it's not going to be hard to do. So this is Cassie's mortgage schedule. Okay. This is the amount of money Cassie borrowed. She borrowed $1,000. That's day one. At the end of the month, it's time for Cassie to make a payment. So she makes a payment. $88.85. Now, because her interest rate is 12% annually, but she's being compounded once a month, her monthly interest rate is 1% or 0.01. Okay? So at the end of this first month, she owes 1% of that $1,000. Which is $10. So of her payment of $88.85, $10 of it went to interest. Which means that what remained to go to her principal and reduce her debt was $78.85. So her $1,000 minus $78.85 gives you her new balance. Everybody following so far? Okay, that new balance then becomes what she gets charged interest on. So she's going to pay $9.21 interest, which is this $9.21. So from her payment of $88.85, we subtract that $9.21, and that gives us how much actually comes off of her loan. $79.64. So this new balance is her old balance minus how much she paid to the principal, and that's $9.21 came from the line above. So it's this number minus this number gives you that one every time. Okay? And the way that you get this number is you take the previous balance times the interest rate. So you take 1% of this to get this, and you subtract that from the payment, and you get an amount that you're going to subtract off of this payment. To get your next balance. And you keep doing that month after month after month. So what you can see happening here is she keeps making the same amount of payments, but the interest drops as she makes her payments, until by the time she makes her 12th payment, only 88 cents of it goes toward interest, because she only owes $87.96, which is really close to $88, and 1% of $88 is 88 cents. So when she makes her payment, she's paid off her loan. Okay? Now, this is for borrowing $1,000 for 1 year. Compare that to the house payment we were talking about, where you borrowed $220,000 for 360 payments, 30 years. And so this changes very, very slowly. And so does this. And so does this. Okay? So in the case of her, let me make sure everything's still the same. Yeah, it is. Because here's where she made her first 3 payments. Payment 1, payment 2, payment 3. This is how much she still owes. If she walks in that day and pays $761.08, she's done. She's paid her loan off. Right? But if she carries out the whole entire loan, she doesn't prepay, she pays $1,066.20. So she saves $305.12 in interest, which is quite a bit. So by prepaying, she saves a lot. Now, the real moral of this lesson here, this is, like I said, this is a 1-year loan at a relatively easy to figure out interest rate, but this is just financial advice for the future, and you might want to think about how this is true. If you do buy a house, let's say your house payments are $750 a month for 30 years. If you'd like to pay your house off and not have to remortgage it, regardless of whether or not your interest rate changes from time to time, the best thing to do is to round your house payment up to the next even $100 or the next even however much you can round up to. I actually have my mortgage amount set to come out at $900 a month, regardless of what they tell me my payment is. I always have them tell you, I figured out that 1 year that I was budgeted for $902 a month. I figured out I could keep on paying $902 a month, so hopefully that'll shorten my mortgage by a few years. Okay? So even if you can't prepay, paying a little extra on each payment means that this still is a little bit higher, which means this goes down a little bit faster, which means this becomes a little less, a little faster. Okay? And you didn't have to have somebody from the stock market tell you that. Does anybody have any questions? Because that's all there is in that last section, is just the mortgage stuff. And that's the only example we have. You will have a test on Monday. It will be just on chapter 5. Just all of chapter 5. And I will post a practice test. I am undecided right now as to whether I'll post it in my math lab so that you can have the practice of doing it over and over and over again, or if I'll make it a paper one. I'm kind of inclined to put it in my math lab right now, because that way it's self-checking and you can do it more than once and get lots of examples. Okay? The only question I've got about that, my day students are telling me that when they use the TBN solver, their answers don't come out to be the same as what my math lab does. Are y'all running across that?
Yeah, the rounding is
Okay, how much off are you?
A penny or two.
Okay, if you're off by a penny or two, click Ask My Instructor and I'll give you credit. Okay? I will give you full credit.
That little triangle pops up and it says, this was your answer, this is my answer.
Yeah.
I'm like, geek, geek.
Okay, yes. If all it, actually, instead of clicking Ask My Instructor, after you finish whatever the assignment is that you're on, go back and look and see which ones that counted wrong that you think are right, and just send me a message either in Shobi or in Remind and say on section 5.2, would you please check question so-and-so on the homework? I think my answers are right and it's counting wrong, and I'll give you credit. And then that way, when you do the practice test, if you're coming off, you know, if you're a penny or two off from what they say the right answer is, well, your answer's right, you're fine. Okay? Any other questions? The reason their answers come out different is because what they do is they round the intermediate calculations. They don't use the formula with the parentheses and everything. They round off the intermediate steps, which means at the end it rounds off the last answer by a little bit more than it should. You're probably coming out with probably a penny higher on a payment or a penny less on a future value.
I just know it.
Yeah, they told me they were aggravated about it, and that's why I wanted to mention it to y'all. So if there's assignments where it's counting your problems wrong, don't keep trying to do them over and over again to get a right answer. If you're within 2 cents, one way or the other, you're right. Just write down that problem number and ask me, and I'll go give you credit for it. I can do that. I can override. Okay? Anybody have any other questions or concerns? Questions on homework you need to see? I did go ahead and open up the notes on the first section of chapter 10. Some of you have seen it before, some of you may have not seen it before. So I wanted to go ahead and open it up and let you look at them when you had time, so that you get an idea of how much time you needed to have to go into chapter 10. That's the only section I've opened up, because I'm modifying the rest of the sections of chapter 10 that we cover, so that the assignments will be shorter and it'll focus on the stuff that I know you need to know for the test. The other thing that I've already done, I'll just show you where this is. Because I'm aware of how much time we have left too. We've got about 3 weeks to the end of the semester. Your 5.3 homework says here it's due on Wednesday. The reason that I've got the Shobi homework due on Wednesday, and some of you have already turned it in, the reason I've got it due on Wednesday is if you're having problems with 5.3, I want to know it before you take the test, not after you take the test. So if you'll go ahead and get that done, even if your answers are wrong, I can tell you what you're doing wrong, and it's not going to hurt your grade any. Just go ahead and get those done. This is the section 10 notes and homework. And the Shobi homework is right in with the notes. So there's not a separate homework folder for the Shobi. You'll just load up just those whatever pages it says try your turn. Let's see if I can find one. Okay, so there's well, actually, I think there's 4. No, there's just 2. There's just 2 problems on homework for that. And it's asking you questions about domain and range and putting numbers into functions. So that's all I've got up there right now. The other thing that I opened up, at least I thought I did, I may need to look see if I did or not. I didn't open yours up. is the final exam study guide, and I think these are different. Let me look. One of them's the old one and the other one's the new one. Yeah, this is the new one, and it's more like the new test than the old one is, but the old one has similar problems, so you can use that for practice. And that's actually the formula sheet for it. Stop that. And then if you're interested, I've already done a video of the new study guide, which is this one, and it's up in YouTube. Make sure the sound's working.
They don't require me to actually show you the calculator instructions. Those will be included in a separate report, so that I can have both the calculator and the answers on the same screen.
Okay, so those are
So you'll follow number one, which is.
the ones that are done strictly on the calculator. There is a separate recording, and I haven't posted it yours yet because I need to finish it. Just so that you know, all of that stuff's there for you, so that you don't have to wait for it if you want to go ahead and start reviewing. So I think that's it, unless y'all got questions.
So, we have, after chapter 5 test, we have chapter 10, and then the model is for chapter 10.
I'm hoping by going ahead and starting chapter 10 that I can give you a test over chapter 10 in class the last Monday that we met. And that's why I went ahead and opened up the review, so that you could see kind of what you're gonna need to know out of chapter 10, so that you could kind of focus yourself that way. Yeah, I'd rather we have a separate test over chapter 10, I really would, because it would be better for you to make sure you know how to do things in chapter 10. Okay? Now, I will say that for the most part, looking at the test that I graded, most everybody's doing a really good job.
You ain't got the money yet. Sorry.
Yours is one of the ones I'm using for the key. Okay?
Well, that's a Thanksgiving miracle. That's a miracle.
When if I give you time, y'all do a really good job on those, so I'm not really worried so much about you guys' grade. So there are some people that they're not in this room, there are some people that turned in a lot of blank paper, and those are people that I think probably should have taken an internet class.
Never take an internet class. Ever.